Hi everybody. My name is Jared Longfox. I am the one of the hosts of this AIAA Space Resources webinar series, one of the education and outreach efforts ongoing by the AIAA Space Resources Technical Committee. So today we're fortunate enough to have Rob Mueller from NASA Kennedy Space Center SwampWorks here presenting, and I'll let him give the title of his talk and everything. But before we get started, I did just want to mention Rob will give his, as usual for these, for regular attendees, Rob will give his presentation, and you guys are free to punch questions in the Q&A down on, should be on the bottom of your Zoom window. Punch questions in there. We'll get to them all at the end. At some point in the webinar here, I will post a link to the Space Resources Technical Committee YouTube channel where you'll be able to find this video and the rest of the webinars we've done over the past few years uploaded to YouTube for future reference, as well as a link to the repository where we keep the slides that correspond to the webinars. So with that, I will kick it over to Rob to give his talk. To save bandwidth and focused attention, I will be going off camera, Rob, but if you need anything, I'll be here in the background. Let me know if you need anything.
Okay, great. Thank you very much, Jared. Hello, everybody. I'm going to share my screen and my presentation, so please stand by. Okay. All right. Do you see my full screen?
I do. Looks great.
Okay. Well, let's get started. So this is a presentation for the AIAA Space Resources Technical Committee webinar series, but it's also in collaboration with the IEEE Institute of Electronics and Electrical Engineers and also SwampWorks, which is an innovation lab at NASA Kennedy Space Center. I do work at SwampWorks. I'm a co-founder of SwampWorks. I'm a senior technologist. And some of the slides I will be talking about SwampWorks efforts. Other slides I'll be talking about IEEE work, which I volunteer for the IEEE. So just keep that in mind that some of this is not NASA work, but it's something I'm doing as a volunteer. So first of all, I'd like to talk about the outline. I'll get into some hypotheses that I'm going to lay out to begin this talk. Then we'll get into some history examples. NASA has a program called the Centennial Challenges Program. I was personally involved with three of the challenges. They've had over 20 challenges, but the three that I was involved in, I'll talk to you about those. Then we'll talk about NASA Lunabotics, which is a competition for universities. The NASA Swarmathon Challenge is another competition we had. And then we did some crowdsourcing with the GrabCAD Bucket Drum Excavation Challenge, so we'll talk about that. Then this year, Caterpillar sponsored a joint competition for universities for lunar autonomy, and that was with NASA and the Lunar Surface Innovation Initiative, the Lunar Surface Innovation Consortium at Johns Hopkins University. Well, that just ended this summer in May actually, and that was successful. And then the big event I want to talk to you about is the IEEE Telepresence competition at something that's new called the Robopalooza Space Festival, which is something that I started, and it's a collaboration with IEEE, AIAA, and ASCE, and a variety of other organizations. So I'll get into that, and then we'll draw some conclusions. So first of all, I'd like to lay out some hypotheses, which to me seem obvious, but let's see if everybody agrees. So first of all, I'm claiming that the inspiration through technology development and operations challenges can lead to accelerated innovation and develop a motivated workforce. So the hypothesis here is that if you have these competitions, it radically motivates the workforce and it leads to accelerated innovation because of the environment it creates. So that's one hypothesis. The second hypothesis is that competition is healthy and stretch goals create personal and professional growth. This is just something I've observed over the last 15 years of running these competitions. And it's really amazing to see how people grow in these competitions. And it's a very healthy thing because it's teamwork. It's teamwork and it forces you to push the boundaries of your capabilities and it gives you a lot of self-respect. And that's really healthy. The third hypothesis is the best form of public inspiration is to demonstrate innovation in practice. I don't really believe that a big advertising campaign is that effective. I think what's more effective is to actually do it. And when you do it and show it to the public and it's innovative, that speaks for itself. For example, when the Starship launches, they don't advertise it. It's just amazing. And that's what we need to do. The fourth hypothesis is the United States and the world can benefit from new designs, methods, and businesses that will expand human civilization into the solar system to benefit from using the vast quantities of space resources. I often get the question, why are we doing this? The reason we're doing this is we want to benefit from the vast quantities of space resources. That's one of the reasons we're doing it, but it's one of the main reasons we're doing it. And so that's another hypothesis. I also believe that if you don't know why you're doing something, you shouldn't be doing it. So that's what I'm laying out here. And now we'll try to test these hypotheses by going through some case studies from the past 15 years of running these competitions. So first of all, these challenges, they're nothing new. We've had challenges from 1700 to the 1900s. The first very famous challenge was the Longitude Prize, which led to John Harrison's marine chronometer. And I won't get into all the details of this, but if you're interested in it, look it up. It's a great story. Then Napoleon. Napoleon had the troops going out. They couldn't find any food. They needed to bring food. The food wasn't lasting, so he laid out a food preservation challenge, which was won by a baker. And essentially, it became the technology that allowed humanity to preserve food in canned goods, and that was very, very effective for all kinds of endeavors. In 1863, there was the billiard ball prize. Billiard balls were made of ivory, and that's just not sustainable. And so they had a challenge for inventing a new billiard ball material. And John Wyatt made a billiard ball out of cellulose, and that led to the development of modern plastics. And in 1927, the Ortig Prize was incentivized Charles Lindbergh's solo transatlantic flight. So he was a pilot, he was an airmail pilot, but he was able to win the prize, and it really changed his life and changed aviation's history. So these prizes are highly effective. They've really changed history. In 2004, Ansari X Prize was revived the concept. So there hadn't been any prizes in the late 1900s. And then in the 2000s, this principle, this type of concept was revived. And then Burt Rutan, who's a very famous aeronautical engineer, he invented the Spaceship One, and that won the Ansari X Prize, and that's now become a commercial thing under Virgin Galactic. So these cases show how non-traditional innovators, clockmakers, bakers, pilots solved major national challenges. So it's a proven method. If you have these challenges, you attract people from different walks of life, and then they are able to bring new perspectives and bring innovation to the table. So by the same token, because these challenges have been so successful, in 2005, United States Congress mandated NASA and other federal agencies to try to use challenges to encourage innovation. NASA started the Centennial Challenges program, and it was focused on propulsion, robotics, ISRU, materials, food tech, ISRU's in situ resource utilization. And so these are the problems that we need to solve in the space industry. And the motivations for change would, they're like times are changing. We used to have big programs with a lot of money and a lot of resources, but but that's not really true anymore. We have to do more with less. So there's budget constraints, technology gaps, things are getting more complicated. Not everybody works for NASA. There's other people in other industries that are extremely intelligent and qualified, so we should take advantage of that. So it's a form of crowdsourcing. And it's also democratization of technology developments. The tools that used to be specific to NASA, like NASTRAN for finite element analysis, those are commonly available now. And there's also a lot of open source software, open source analysis tools. So this is a full-on democratization of technology. And then there was $20 million awarded in prizes, 400 teams engaged in 20 in over 22 challenges. So you can find out more about this in an AIAA paper that is out there and has been published. But the statistics do show that this is a way of incentivizing the public and non-traditional players to get involved in the space industry. Now, I was personally involved in uh, three Centennial challenges. They're listed here. And my lab, the SwampWorks Granular Mechanics and Regolith Operations Lab, they were instrumental in helping out with these challenges. And so the most recent one was the Break the Ice Lunar Challenge, which is excavating frozen regolith, frozen dirt, and that was successfully completed in 2024. The goal was to show that a rover, a robotic excavator, could excavate 800 kilograms per day of frozen regolith in an offloaded condition. So they hung the robot from a crane and then offloaded it, and then it had to show that it could excavate this very hard icy regolith. Then in 2015 to 2019, I was heavily involved with the 3D printed habitat challenge, and that was focused on autonomous construction of planetary habitats. So big robots with new materials, extruding these materials in additive layers, going one layer at a time, stacking these layers and creating a habitat. So there was architecture involved, engineering involved, material science, civil engineering, robotics, controls. So it's a very multidisciplinary endeavor, and we had some good success here. We had a lot of attention from the press, a lot of attention from the public, and some of these teams have been commercially, I would say about 4 to 5 of the teams that were involved in this competition have had commercial success. So that was really the best outcome. And then the regular excavation challenge was 2007 to 2009. I was one of the initiators of this challenge, and I learned a lot of lessons from this challenge, which I'll talk about in the next slide. But we did establish the feasibility of excavating with small robots. So a 500 kilogram robot on the moon will only weigh about 82 kilograms on the moon, 1/6 gravity. And it wasn't obvious that with that kind of a reaction force from such a low weight, that it was possible to do this excavation at all. So we did prove that it's feasible, and we also established some excavation rates, which helped us in future mission planning. So that was a big benefit. So the broader impact of the Centennial Challenges program is that we have $20 million awarded. Startups have come out of this. For example, Maston Aerospace was a result of the initial lunar lander challenge, vertical takeoff, vertical landing. And so there is a good history of innovation and getting incubation funding for these young companies that are trying to do innovative new technologies. And then things have changed. Rapid prototyping is extremely easy these days. Tech infusion, public engagement, the world we live in, information travels very quickly. So we can really do more than we have in the past. So after the regolith excavation Centennial Challenge was over in 2009, we were happy that it had a good result, but we were also kind of sad because it didn't continue. And so a group of us sat around brainstorming, and we decided that in that Centennial Challenge, the teams that were the most successful were the university teams. The big companies, they didn't show up. It wasn't worth it for them. Small companies did show up, but they didn't have enough resources. The garage inventors, they didn't have the time. And the small company, they just didn't have the backing, the financial backing to do it. So really, it was the universities that were doing the best. And so we decided to focus on those users, those participants. The university teams were getting the most value out of it, and we were getting the most value out of the research that the university teams were doing. So we decided to do a spin-off from the Centennial Challenge, and the spin-off was called Lunabotics. It was another competition. At first, we called it the Lunabotics Mining Competition. These days, it's more of a construction competition. Originally, it was mining regolith for ISRU, oxygen extraction, and that was started in 2010. And we said, what's the success criteria? Okay, 5 teams. If 5 teams show up, we'll be happy. Well, that first year, I think we had 40 teams or some big number apply, which meant, there was a lot of interest out there. And so we have continued to nurture that competition and promote it and run it for the last 15 years. And it's still going strong. So we're doing something that's of value to the universities. The specifications for Lunabot has to be a robot controlled remotely or autonomously. The rules are heavily incentivized to do autonomous excavation and traversing. The operators are isolated. They're in a control room. They can't see the robot. They have to operate through the cameras. One of the things that makes this competition unique is we actually use regolith simulant. So it's very lunar-like. We don't use sand. We don't use anything that doesn't simulate what happens on the moon. And it's not really obvious. When the students show up, they always say, well, this regular simulant, it doesn't behave like what we practiced in. And we say, yes, that's why we use it. It's very different. The geomechanical properties are very different than beach sand or playground sand or volleyball court sand. It's just different. And we asked the teams to build a berm structure with the excavator regolith because a berm is a very useful thing to have on the moon. A mass limit is 80 kilograms for these robots. They cannot be bigger than 1.5 by 0.75 by 0.75 meters. They have to be designed, built, tested, and operated by only university student teams. You can't have companies or professionals involved. And they must use NASA systems engineering methods, which is really the big deal here, is they can apply NASA systems engineering to any future job, whether they build a robot or they build a motorcycle or any kind of other device. NASA systems engineering is very useful. So we're kind of a victim of our own success. The competition got too big and we couldn't handle all the teams at Kennedy Space Center. So we ended up having a UCF qualification event at the University of Central Florida. And they have, at the Exolith Lab, they have built a very nice regolith bin containing lunar Highlands regolith simulant. It's 10 meters by 10 meters by 1 meter deep. You can see a diagram of it here. So that's a really unique facility. And we use that for the qualification event. Then once they finish the qualifications, the top 10 teams go to Kennedy Space Center, and we have a smaller bin there. It has Black Point 1 regular simulant, but it's still very good. And at UCF, we divide the bin into 2 lanes. Here, we don't do that. We let them use the whole bin because it's the final, and that's been a very good simulation of the lunar surface for excavation. If you look at the regolith, it's really the steep sidewalls. That's an indication of a high angle of repose, which shows how the lunar regolith behaves on the moon. This is very similar to the pictures we saw from the Apollo program. If you do a vertical cut on the moon, that vertical plane stays vertical. It doesn't avalanche down. On Earth, that would, if you used a regular soil, it would probably avalanche. But on the moon, because of the reduced gravity and the van der Waals forces, the electrostatics, and the high internal angle of friction and the cohesion, it all sticks together and it creates this rigid vertical wall. So that's why we have to pay attention to the geotechnical properties of regolith because it really behaves differently from what we see here on Earth. We partnered with a company called Regal, and they provided LiDAR scanning of the berm, which was also really useful. We now get the 3D volumetric dimensions, and that's lets us, within 4 minutes of each competitor finish their run, we can now get the results. So that's another result of new technology. The types of Lunabots that show up, we did a little inventory, and it's typically it's the bucket ladders that show up. Bucket ladders, bucket belts, bulldozers, scrapers, those are the most popular machines. And you'll see an example of each on the screen here. Uh, this is kind of democracy, the teams are voting with their robots, and most of the teams think that the bucket ladder is the way to go. I think that is the way to go for the competition because we only give them 15 to 30 minutes to excavate. But on the moon, you have a lot more time. And so your trade-off is not so much speed, but it's more reliability. So we're encouraging the teams to build robots that are more reliable, more lunar-like, but most of the times they want to win, so they go for the quickest digging device they can think of, and that's usually a bucket ladder. So, that's an interesting thing, but it shows you that the way you structure the rules for these competitions really affects the outcome you get. So you have to think very carefully about how you structure those rules because you might be biasing the designs. And by having only a 15-minute regular excavation run, that does bias the design. So something to think about. Overall, the Lunabotics back to the hypothesis is like, do these competitions, do these challenges, do they work? Well, I would say that based on the evidence from the Lunabotics, we've had 40 to 50 universities have participated in each of the past 16 years. Now, if we assume an average of 12 students with each team, 720 teams have participated, that's over 8,640 students have been challenged and learned new skills which are relevant to today's industry. A lot of these teams use it for senior capstone design projects, so the professors love it because they get a 2 semester structured class that we provide to them based on systems engineering, which results in building an actual piece of hardware with software and controls, and then you go on a mission to Florida. So this is really a great way of training people. Most of the students reported that when they went to their interviews, they had an edge in the interview because they had something to talk about. They could talk about this exciting Lunabotics experience that they had, and the employers were interested because that was a little bit different than the other 200 people they had just interviewed. So it gave them an edge when they're applying for jobs, and that's a good outcome too. And then also our sponsors, they love to hire those students. So the sponsors come to the competition, they interview the students, they watch the students, they look at the hardware that's been built, and then they hire who they think is the most qualified. And so that's really all of these things show that these competitions have evolved into a successful model. If it wasn't successful, then we wouldn't have been able to keep this going for 16 years. I'm not saying we can't do things better. We can always do things better. But the basic uh, outcome, I think, is to inspire the students, to give the students a good experience, and that is working. Another competition we had was a NASA Swarmathon competition. It was a collaboration between NASA Kennedy Space Center and the University of New Mexico under a NASA MURAP grant. That's for minority universities. And so that was held from 2015 to 2019. It was designed to foster the development of autonomous cooperative robots called Swarmies, these little robots we made. So New Mexico, the University of New Mexico made over 50 of these little robots and sent them out to the universities. And the task was inspired by ant behavior. So it's biomimetics. It's mimicking ant behavior. Each robot is like an ant, and the resources are those little cubes you see on the right-hand side with the barcodes on them, the April tags. And so they were programmed to work collaboratively following a virtual pheromone trail, and then they were tasked to collect as much resources, as many cubes as they could. And so this was also a very successful competition, and we had non-traditional universities showing up, universities that um, you don't usually hear about. So they had a good experience. Another thing we did, we went and crowdsourced a design. So the GrabCAD Bucket Drum Excavation Challenge. GrabCAD is a a resource online for CAD models. So you can buy and sell CAD models, share them, they also run competitions for CAD-based entries. So nothing is built here. It's all just virtually designed with computer-aided design packages. So our task was we have this robot we call Razor, the Regolith Advanced Surface Systems Operations Robot. That was a prototype. And we asked them to, how could we improve the bucket drums, which is what you see on the end of those two booms? That's what does the digging and dumping. And we thought maybe we'd get some good ideas on how to improve the design and increase the capacity. So we did get, well, I'll go back. We got 314 entries, and they were pretty good. Most of them were pretty good. And we had a jury of engineers assessing these, and the engineers assessing them were actually the designers of Razor, so they were very familiar with the problems and design criteria. So the number one design is on the top left here, and this design eliminates the internal baffles of the bucket drum, and so the fill ratio was two or three times higher than what we have on the current design. The disadvantage is it has this flap here, which is a moving part. So our design doesn't have any moving parts at all inside the bucket drum, but this does have a moving part. So now it becomes a trade on capacity versus reliability of that moving part. But you could argue this is a very good design, and we have seriously considered it for the lunar versions of Razor, which I'll get into in a minute. So I would say we had a good experience with the Grab CAD Bucket Drum Excavation Challenge because it was crowdsourcing. We had good response, and we had some very interesting ideas. It caused us to think about our design and see if we could improve it. Uh, Once Razor was proven in the lab, we were asked to scale it down to a robot that's half the size of Razor so that it could fit on a CLIPS, a NASA CLIPS mission, uh, cargo, lunar commercial payload services. And so the payload on those landers is usually pretty small. It's maybe 100 kilograms. So we couldn't really put a whole Razor on. Razor weighs about 66 to 70 kilograms. And then you have some other systems that could increase the mass more to attach it to the lander. So we redesigned the whole robot and we call this IPEX, the ISRU pilot excavator. And that is now a much smaller robot. It only weighs 35 kilograms and it's about 40 kilograms when you have the attached hardware and some other things that you need on the lander. But we have achieved TRL 5 in the development cycle of this robot, and we're a candidate for a future lunar tech demonstration mission. But here's some pretty interesting statistics. If we get the chance to fly, we aim to traverse a total of 70 kilometers in the lunar environment. That's 1.5 times the current state of the art. We're also doing trafficking over the same terrain 350 times. So there's an open question on what happens to that terrain when you traverse over it over and over again. That's 70 times the current state of the art. We'll move 10,000 kilograms, 10 metric tons, over 100 meters over 11 days. So we'll dig, travel, dump, dig, travel, dump. We'll keep repeating that over 11 days, and the total amount of regolith excavated is 200 times the current state of the art. If you have the distance traveled and the payload of regolith moved all added up. So this small robot here is going to set several records. and that's exciting. So because of that, Caterpillar has been a good sponsor, good friend of NASA's, and they're interested in the skills. They're interested in developing a pipeline of talent that they need for their autonomous construction machines. So to incentivize students to study autonomy and do research in autonomy, they partnered with us and Johns Hopkins University to run the Lunar Autonomy Challenge. And so this it's a competition for university students to develop algorithms to autonomously control this lunar excavator called the IPEX. And so we had this competition. It was very successful. We had a good turnout. 31 teams applied. It was narrowed down to the finalists. This is a list of the finalists. First place was given to Stanford University, second place MIT, third place Carnegie Mellon University. So that ended on May 15th, but another example of how a competition can really incentivize students to do excellent work. And this is the kind of work that Caterpillar wants for their industrial mining and excavation and construction machines. And they wouldn't be sponsoring it if they didn't think it was relevant. So a lot of future jobs are going to come out of these skills. Now, the last thing I want to talk about is the IEEE Telepresence Initiative. So this is a new initiative by the IEEE, and their goal is to accelerate the move towards a telepresence society. So I think the world understands that telepresence is certainly possible today. And now it's a matter of how do we integrate it into our activities and make it useful. And that's already happening everywhere today. But this is an initiative to focus on the technologies needed to make this a reality where we can be in one place and work in another place or have a good experience in another place. It might be entertainment, it might be work related, it might be family related. You know, how many families feel closer now because their grandparents can see the grandkids on an iPhone. You know, this is all part of telepresence. Well, what if it was even better than that? So, and surgery, for example, telesurgery, you know, there are a lot of benefits for society from telepresence. So this goal intends to provide vision, direction, help create the future. So it's really a community building effort. The Telepresence Initiative organizes workshops and they have an annual conference. So last year they had a conference at Caltech in Pasadena, California, and they had 44 papers, 90 attendees, so not bad for a first year of a conference. They published a white paper for roadmap, and then they asked me to organize a telepresence competition in the Mojave Desert, which was close to Pasadena, about an hour and a half drive away. And so we did that, and we had seven teams, nine exhibits, robotic companies exhibiting the robots. 300 people attended from the public, and we also had press coverage from National Public Radio, which was very positive. And so the outcome of that competition, well, one of the things we learned was, yeah, telepresence is great, but it's not great for spectators because the competitors are not there. The winning team was in Australia. So, you know, they weren't there. There was nothing to see. So we had to wrap it up into more than a telepresence competition. I'll get into that in a minute. But because the competition was successful last year, IEEE has offered to sponsor it again this year. They're having a second conference. It's going to be in Leiden in the Netherlands in early September. And our telerobotics competition will be in Australia this year and I'll get into that. But the roadmap is there. Then the IEEE Telepresence Initiative schedule is down here. You can see they have the conference September 8th to 10th. We'll have the Robopalooza Space Robotics Festival October 5th to 7th in Perth, Australia. And they have other conferences too. So if you're interested in getting into telepresence activities, there is a whole community that's developing through this initiative. So I'll just quickly go through the outcome of Robopalooza. What happened was we couldn't have just the competition because there was nobody there. So if we invited the public and there was a robot driving in the field, it wasn't very exciting. And so uh, after some thought, I decided that we had to have it, it had to be more. And also based on the competitions from the past that I just explained to you, they were all good, but they weren't great for the spectators. They were great for the competitors, but if you were a spectator, it was slow, it was difficult to figure out what was going on. There wasn't too much excitement because it was all happening inside the teams and hard to explain to spectators what's going on inside the team environment where they're all sweating bullets trying to build a robot. So it really wasn't good for the spectators. So we had to do it differently. We had to make it better. And the way we did that is we made a festival out of it. And the festival is called Robopalooza. And again, that's kind of like a little bit of marketing there, just trying to get everybody interested. If I say, would you like to go to the IEEE telerobotics competition? That's I don't get a very good reaction. But if I say, hey, would you like to go to Robopalooza? Everybody said, what's that? So, it's just marketing. So we were at the telepresence site. It's a remote site in the Mojave Desert near Peterman Hill, and very soft dirt, very Mars-like, and high winds. We had that tent that's shown in that picture, and next morning there's the tent. It just blew down and crumpled. So it's hard to operate. It's extreme environment, extreme engineering, really good for testing, but not good for holding an event. Robot, we it was hard to find a robot that was available. So what we did is we partnered with the University of Hawaii. Pisces is a group at the University of Hawaii, and they loaned us the 700-pound planetary rover, and you see pictures of it here. So that was a very good partnership, and that was successful. The robot, what the telepresence competition was, it was a race, and it was a slalom race. You see that the cones. I'm sorry, this keeps moving on me. There's traffic cones, and we laid out this course, and then the teams had to slalom around the traffic cones, and then you'll see that little hill, and we put up the US flag on the hill, and the robot had to go capture the flag and then bring it down the hill and then keep going through the slalom. Team that did it the fastest won, but if they hit a cone, then they had a time penalty, which was subtracted or rather added to their time. So the fastest time won. If they hit a cone, they had a time penalty. So that worked quite well. We had this robot race. We had 7 teams from Australia, Chile, the United States. Winning team came from Australia, and we had local robotics companies from the Los Angeles area that came up and showed their robots, and we had National Public Radio there. About 300 visitors attended, a lot of students. So it was very, very good, but we can do better. And so this year we've got an amazing competition lined up. It's going to be in Perth, Australia, and there's our logo on the left. And here's what really why it's going to work, or why we hope it's going to work this year, is because there's a lot of things going on in Australia this fall. In on 29th of September to 3rd of October, we have the International Astronautical Congress, and that will be in Sydney. So a lot of people will be in Australia anyway for that conference. They have over 7,000 people attending. Then the weekend after that, the 5th and 6th of October, we'll have the Robopalooza. And then the weekend after that, the week after that, from the 7th to 8th, is another robotic conference in Perth. So, and then there's a lot of mining events throughout the year. And this Robopalooza is designed to be collaboration between the terrestrial mining industry and the space industry to promote innovation. Now we have this really great facility called the Australian Automation and Robotics Precinct, AARP. I'm going to play a video. So, can you see the video? Hold on.
I can see the video.
I'm going to start
Um,
it from the beginning. I
okay.
don't think you can hear the sound, can you?
Not on my end, no.
Okay. Well, I'll do a voiceover. It's just music. Uh, and so you can see the goal here is to do telerobotics. And telerobotics means driving a robot without being in the same location. We did have a $5,000 prize, US 5,000 US dollars in 2024, and we have the same thing again this year, $5,000 prize. These are the teams that attended, and they two were on site, but the rest were remote. And that's Peterman Hill in the background. This is the slalom course. You can see the rover is traveling pretty fast. It's not very fast, but it's fast enough that it's challenging. This is the facility in Australia that we're going to. It's a brand new facility. It cost $27 million to build it. It was really built for the mining industry, and the mining industry is interested in telepresence, teleoperations, telerobotics, and autonomy. And so they're very interested in what we've done on Mars and what we will be doing on the moon. And so that is the goal here is to, can you see my slides?
Yep, looks good.
Okay. So I've got the QR code here, and you can go to their website. It's the AARP.com. You can learn more about that facility, but that's where we'll be going to have that competition. So this event will be the competition is one part of the Robopalooza Space Festival, and it will be live on YouTube. The competition has 8 competitors. Will run 1 hour each during the second day of the event. The first day of the event will be practice runs. The winning team gets $5,000 prize to be evenly divided between the competitors. It's okay if you're international. You can be from anywhere in the world. There's no problems with that. You do have to be over 18 years old, though. Uh, and you can have as many people on your team as you want to. You just have to split the prize among your team members. We'll have STEM education. We actually have a 3D printed razor robot that I'll talk about in a minute that is available, and it will be demonstrated there. We'll have startup company pitch battle. So there will be a prize for the company that wins the pitch battle. They'll get 30 days of free testing at the Australian facility I just showed you called the ARP. So that's free testing as a prize there. We'll have robotics demonstrations from industrial partners. We'll have live rock music and cultural festivity and food trucks. So that goes back to the spectators. You know, if you don't offer anything to the spectators, then it's a boring event, and we don't want that. So we're gonna make this a pretty exciting thing. We're gonna have a rock and roll climate. We're gonna have just a lot of good vibrations. So that's how we keep all the spectators and the general public interested. With the audience we're looking for is competitors and industry experts, STEM students and educators. So the first day is all about STEM, the second day is all about industry, and we're inviting the general public in. We've already had 500 tickets sold, and the price is zero, so that's a good price. But anyway, we have 500 people who have asked for tickets in the each day, and we're trying to increase the capacity, but it looks like there's quite a lot of interest. Now, we do need some more interest. This is the last call. August 31st is the deadline. We have a pitch battle for new companies, mainly startups, but it doesn't have to be a startup. It can be any company that wants to raise funding for their technology. And we have a student pitch battle too, where if a student has a great idea and they want to get some attention from the judges are all venture capitalists. This is a great way to raise some money. But the IEEE telepresence competition, we have openings for 8 teams, and we still haven't filled them all. So I'm looking for more competitors in the telepresence competition. So please take a look at that. Got all the QR codes here, and you can go to the website and find out more information. Website is robopalooza.space. But if you're interested in being a competitor, or you can pull together a team of people to be competitors, please do that. We need your entry by August 31st. It's just email a PDF form in where the instructions are on the website, but it's simply sending in an email. But we do need more competitors at this time, so please consider that. We'll have professional robotics demonstrations, and I'm arguing that space and mining together will create a lot of innovation. There's a lot of incentives. Mining industry is capital intensive. The space industry is very focused on advanced technologies. So put those two together, and I think we can uh, get some innovation going, some new possibilities. We have a lot of STEM activities going on. We have these organizations that are all promoting STEM is science, technology, engineering, and mathematics. So it's really, if you don't have those skills, you're not going to do very well in the 21st century economy. So it's important to get those skills going, and that's why we're trying to promote that to the youth here. So this is what I was talking about. On the right is the Razor robot from the Swamp Works at Kennedy Space Center. And then we created this small 3D printed version of Razor we call the Mini Razor. And we partnered with the University of Central Florida, and they've in their capstone senior design projects, they've written software for it and created CAD files, which are all open source. They can all be downloaded at this link that I have here at the Florida Space Institute. And here's an example of what one looks like. And then you can program it and do your own experiments with it and gain some skills. So that's all available, and we'll be demonstrating some of those at the Robopalooza. And actually, one of the visions I have is for thousands of teams across the world to build these at home and then bring them to the Robopalooza, and we'll have a big swarming robot event. So anything's possible here. We just have to use our imagination. Now it's not just STEM. The A in STEAM, if you add A to it, it's become STEAM, and A stands for arts. And then in the arts, we're saying that the music is part of the A, the arts. And so we'll have these rock and roll bands. It's going to be some opening bands, and then the headline act is the Six Footers. They're a local Australian band in Perth. And so we're trying to make this an exciting event. I think it's going to be a lot of fun. That's it. I'd be happy to take any questions.
Awesome. Thank you, Rob. Really cool stuff. And Rob mentioned this at the beginning, but like he said, this is an AIAA co-sponsored event. So um, AIAA is going to be advertising it. Those of you who are interested in this webinar series, the same organization that supports this supports that, as well as the ASCE, American Society for Civil Engineers, Regulatory Operations, Mobility, and Robotics Technical Committee under the ASCE Aerospace Division. So community-wide effort here. And Rob, thank you for spearheading these events throughout your career. Over 1 decade of effort at this, we've come a long, long ways. So with that, let me go to the Q&A, and I don't see any in there yet, but I actually have a question while we're waiting for some to come in. You mentioned that the for Lunabotics, teams often just want to win the competition. So they build the best excavator for the competition. Um, Kind of a twofold question. How do you think that a competition like that could be altered to more focus on the lunar like aspect and make that a more winning priority? And similarly, what do you think an excavator that focuses on the lunar consideration would how would that be different than what we see with a lot of bucket ladders and stuff?
Well, I think the main thing is reliability. We're operating in an extreme environment, and we don't have the luxury of repairing robots yet. We will in the future, but we have to think about system reliability. So this may not be, you can spend a lot of money making a robot very reliable, making a machine very reliable, or you can let it fail and bring a new machine online, put the old machine offline in a repair yard, and then they can repair it offline. Because where things get expensive is if in production, if you have a failure in production, you have to keep production going. So you have to think more about system reliability. And so if you achieve system reliability with less reliable robots, but you have more of them, then it's possible you can still achieve your system reliability. But that's really what we need to achieve. Now, as far as the competitions go, We need longer competitions. We always try to squeeze all these competitors into 30 minutes, but we can't do that. We have to have longer. Time is a variable that is available on the moon. We have a lot of time. It's not like Earth yet. It might be in the future, but for now we have quite a lot of time, and so we have to think more about system reliability and think about how we can stretch things out over time and still achieve our results.
Well put, well put. Thank you. Good information. I see in the Q&A, Eric Franks asks, what do you see as the steps for lunar development beyond Artemis 3? Landing pads, scientific base, mining?
Can you hear me?
Yes.
Okay, sorry, I hit the mute button by mistake.
All good.
Okay, so that's really um, good question. I'm a little bit biased towards robots, and I think you can get a lot more accomplished with robots in the early phases than you can with humans because the cost is lower and they can be there for longer. In the first few phases of the Artemis program, we won't be there for very long. We'll be there maybe 30 days at a time, and the astronaut time is very valuable. So it's hard to imagine that an astronaut who's working on scientific research will be doing construction. So what we need to do is have the robots do the construction and build the infrastructure for the astronauts later. So I think we should invest more in robotics and work on early CLIPS type landers and early robotics missions to set up the infrastructure for the later missions of the Artemis program. And I'm almost arguing we need a program in parallel with the Artemis program that's a fully robotic program that has nothing to do with Artemis. It actually runs in parallel with Artemis, and eventually it links to Artemis. But first, it's there to do risk reduction. So you send all the robots up in a parallel program for risk reduction. And then at some point in the future, Artemis merges with this robotic program and everything moves forward. But the trouble with human spaceflight is it's very slow and very expensive. And so economic incentives are hard to provide in that kind of a program. So I think there is some value to doing a parallel program.
That would be really cool. Just need the money to do it, right?
Well, a lot of this will be commercial.
Yeah,
So
true.
that's where it opens up new possibilities.
Yeah, yeah, no, agreed. It's going to be an interesting next few 20, 30, 40, 50 years. So in the Q&A, I see Angel Zarate Villazon asks, I wonder if you have considered whether the rules in this competition on the robot can be used to enable some resource sharing for different teams in future ventures within Artemis and the cislunar economy.
Yeah, I mean, resource sharing, I imagine it means that they work together, or is it mining more resources? I'm assuming it's working together. So we do incentivize that. Teams can work together, especially if there's a community college that wants to work with universities, we allow that. So that's already in the rules. But the teams have to choose to do that. And a lot of this telepresence and this tele collaboration, it's possible these days, but it's still not happening much because of the way we're structured.
Cool, yes. And they did clarify, yes, they meant working together, sharing technologies, components, and
Yeah, we do allow that. We do incentivize that, but it doesn't happen that often.
makes sense. Makes sense. Thank you, and thank you for the question. Next, Jasper Julian asks, what metals is the government looking for on the moon? What's the market size there?
I think the metal that really is low-hanging fruit is aluminum because it's prevalent, especially at the poles. There's a lot of aluminum available in the minerals, and so if we can extract aluminum and at the same time extract the oxygen, and have the aluminum be a byproduct of that. Most aerospace products that go into space these days are aluminum is the go-to metal. It's really cheap. It's easy to machine. It's very reliable in space. So most of what we've done is milled aluminum. So we use monolithic aluminum parts. We avoid bolted or welded joints, and we use a lot of aluminum. So I think aluminum is the first metal that would be valuable. Platinum group metals are not really there on the moon unless they've been deposited by an asteroid impact. There are people that think that is true, but we haven't seen evidence of that.
Oh, I'm muted. Makes sense. No, well put. And that's all I see in the, oh, one more in the Q&A. We've got time for one more quick one. Eric Franks asked, do you see any possibilities for the development of a self-sustaining lunar economy or orbital economy that includes the moon in the near term? That is, commerce beyond merely producing metals for sustaining science missions. If so, what do you think the driver will be for that?
Well, I think there is going to be a lot of economic activity in space, and it's going to be driven by two things, energy and data. And I can't give you the exact way that's going to happen because that will be market driven, but I'm pretty sure whatever we do in space, the early phases, it's going to be driven by energy and data.
Well put, makes sense. Then, all right, I have one more that we're going to squeeze in here. Sam Zymenes asks, do you think the selected Artemis 3 landing site will be the same site that is developed for a permanent base? Excellent question.
So the Artemis program has not committed to a site. There are, I believe there was 13 sites. They might have narrowed that down by now, but the Artemis programs has candidate sites, but they have not committed to a base. In fact, I've heard that they don't want to commit to a base. They want to have the freedom to go from one site to the next site to increase the scientific return of the Artemis program. So at this time, there is no indication that a permanent base will happen unless there's a commercial reason for it to happen. NASA has not committed to that. You're muted.
Again, uh, that kind of day. So that's really interesting. I guess we'll all keep an eye out to see how all that develops. But for now, we are at time. So everybody, I just did want to point out before we say goodbye for today, I did put in the chat a link to the AIAA Space Resources Technical Committee's YouTube channel where I will be uploading this video within the next day or two, as well as you can find the rest of the webinar recordings there. Also linked is a link to the AIAA Engage page where we upload the slides for these webinars. So Rob's slides will be available as well as the slides of past webinar speakers. You do need a free account with AIAA, but you do not have to pay dues to access these. You just have to be able to log in, and again, that's free to make an account. So, with that, Rob, I want to thank you for your time, expertise, and giving a talk on this really cool topic. I can't wait to see what the next decade of robotics and telepresence competitions gets us. We're getting really close to a lot of really cool tech demos on the moon, and I think these crowdsourcing methods and inspiration methods are really doing their job. So, thank you for giving this talk and for all you've done for this community.
Yeah, thanks for inviting me. And it is a new world we're living in, so we have to adapt. And I think it's good. There's going to be a lot of new possibilities, so it's a good time to be in the space industry.
Agreed, agreed, and a bunch of great people here too. So, with that, we'll wrap up, everybody. Stay tuned for next month's announcement, going out in just a few days. So, hope to see you next month, and please feel free to reach out with any comments, questions, concerns, and we'll go from there. Have a great day, everybody. Thanks again, Rob.